This is the Greenwich everybody knows. The domes of the old Royal Naval College, the Cutty Sark, and above them the Royal Observatory, the place that made Greenwich a name recognised around the world. Home to the prime meridian, the line the world uses to measure east and west, and the place where the passage of the sun across that meridian helped set the time that Britain, and much of the world, came to live by, Greenwich Mean Time. This is the Greenwich of measurement, navigation and time. And now, tourism. But close to it lies another Greenwich, one of brick, coal, chimneys and engines. Greenwich Power Station was built almost on the meridian, beside the Thames, just down the hill from the observatory. At the top of the hill was a place built to notice the smallest movements in the sky. Below it stood a machine built to feed power into London. Smoke and heat rising into the air, engines and machinery sending vibration through the ground. One Greenwich depended on stillness, clarity and precision. The other was made of fire, movement and noise. At the start of the 20th century, the way Londoners moved around was changing. London's trams were already part of everyday movement, but many of them still belonged to an older city. They were pulled through the streets by horses, slow, physical, living power in a city that was growing larger and busier. The London County Council had taken over large parts of the city's tramway system, and now it wanted to electrify it. That meant replacing horses with electric motors, but it also meant building a new system behind the tram itself. Power stations, substations, converters, cables. On many routes, even the way the tram collected its current was hidden, not from overhead wires, but from a conduit beneath the road, through a slot between the rails. So the electric tram was only the visible end of the system. The LCC's first electric tramway opened in 1903, before Greenwich Power Station was ready. But the ambition was already larger than one route. London needed a generating station of its own. Greenwich Power Station was built as part of that larger change. Built by the London County Council between 1902 and 1910, with its first section opening in 1906, it was created to feed electricity into the tramway system. The electric tram in the street may have looked clean and modern, but behind it was a coal-fired machine. From outside, the building can seem almost unreadable. Large, sealed, imposing, a brick enigma on the river. But what happened inside was, in principle, quite simple. Coal came in, electricity went out. The coal heated the water to create steam. The steam expanded and pushed. That push was turned into rotation. The rotation turned the generators, and inside those generators, coils of wire and magnetic fields moved past each other. That movement produced the electric current. So the power station was really doing one thing again and again, turning heat into movement and movement into electricity. A 1907 account gives one measure of the scale. Visitors were shown two large alternators at work, machines powerful enough to supply hundreds of tramcars. So the movement of trams across London depended on movement here, steam expanding, generators turning, current being controlled and sent out into the city. But a machine like this needed more than just machinery. It needed coal, water and space. And to work at this scale, it needed the river. The old pier that bridges over Crowley's Wharf and reaches out over the Thames was where the power station met the river. A power station like this needed coal in huge quantities, and this is where that coal would arrive by boat. After it had been burnt, the waste ash could be taken away again by barge. And the station needed water too, especially to condense the steam after it had passed through the engines. The river offered a ready supply. Greenwich was not the only imaginable place. But after a proposal for an inland generating station at Camberwell ran into problems, this riverside site offered a rare combination: space, river frontage, coal access, and water. Seen from the historic landmarks, the choice can look almost perverse. But seen from the river, it begins to make sense. The land itself was not empty. Part of the site had already been a tram depot. To make way for the new power station, the council also acquired houses and other premises around these streets. So the electric era arrived here in a very physical way. The tram depot was demolished, houses and other premises were cleared, and in their place came the walls, chimneys and machinery of the new power station. For the power station, the location made practical sense. But this was not just a riverside site, it was Greenwich, and just up the hill stood the Royal Observatory. The Royal Observatory was not simply a famous neighbour. It was one of the world's most important scientific sites, and in the early 20th century it was still a working one. Here, observations of the sky helped solve practical problems on Earth. The movement of the sun and stars across the meridian helped make Greenwich a reference point for maps, ships, and clocks far beyond London. But this was not just a symbolic line on the ground. It was work carried out through instruments, observations, and careful measurement. And that work depended on precision. It needed clean air, stable instruments, reliable sightlines, small things staying still. So the issue was not just that a power station had been built near a famous landmark, it had been built near a working scientific site whose measurements mattered far beyond Greenwich. But the alarm came late. William Christie, the Astronomer Royal, began pressing the issue when the first half of the power station was already nearing completion. By then, the power station was no longer just a plan. Brickwork was rising, machinery was going in. The first half of the station was almost ready. The council can ask why the objections had not come sooner, but from the observatory, the answer was simple. The work of Greenwich was now at risk. Some of the threat was visible. Smoke could obscure observations. Heated air could disturb the view through the telescope. But the most delicate problem was not the smoke above the hill, it was the ground beneath it. The first phase used large reciprocating engines. They moved with force, enough to send tremors through the ground. At the observatory, some observations used mercury as a reflecting surface. It needed stillness. Even the slightest tremor could matter, because precise observation depends on things staying very still. In the street, electric power meant progress. On the hill, that same progress could disturb the measurements Greenwich depended on. That was the real collision, measurement against machinery. The problem had no clean answer. The observatory's work was essential. The power station was needed. And by now, the building was already there. So the outcome was not victory, it was compromise. The second half of the station would be built differently. Instead of more large reciprocating engines, it would use balanced turbine sets, machines designed to spin more smoothly and send less vibration into the ground. The older engines were not allowed simply to run as before. Their use was restricted during the hours when the observatory's work was most vulnerable. And the station could not simply keep expanding beyond what had already been planned. The skyline became part of the compromise too. A parliamentary committee recommended that the two remaining chimneys be kept shorter. The original taller pair would remain for decades, until modernisation work in the early 1970s reduced them to match. The station stayed, but it no longer stood there entirely on its own terms. The work of the observatory had been important enough to make the power station change. The trams have gone, but the power station did not disappear with them. Later, after London Underground switched to the national grid, Greenwich became its emergency power supply. Not to keep the trains running as normal, but to provide enough power for passengers and staff to be evacuated safely if the grid failed. From the outside, it still speaks of coal, steam, and the electric city that built it, but its purpose keeps changing. The pier no longer brings coal to the boilers. The station no longer burns coal at all. Its turbines now run on gas, with oil kept as a reserve. And when oil is needed, it comes by road, not by river. But the old relationship remains. At the top of the hill, the Greenwich of measurement, navigation, and time. Below it, by the river, the Greenwich of brick, chimneys, and power. The argument that shaped this place has gone quiet, but the shape it left behind is still here.